We know atoms are really, really small, and so their masses then are really small too. In chemistry, we use relative atomic masses. It's just more convenient. And the mass that we use is based on an atom of carbon-12. Carbon-12 was arbitrarily given a mass of exactly 12 atomic mass units. 1 AMU then is exactly 1/12 the mass of a carbon-12 atom. Hydrogen then is 1/12 the mass of an atom, or 1 AMU. Which leads us to the mole. The mole is a chemist's counting unit. You know that a dozen means 12. Well, a mole is a slightly larger number. A mole is 6.02 times 10 to the 23rd of whatever it is you're counting. It's also Avogadro's number. The number of particles in exactly 1 mole of a pure substance. And that's how many particles there are in exactly 12 grams of carbon. So, 12 grams of carbon is equal to 1 mole of carbon. 1 mole is also equal to the atomic mass of the element expressed in grams. This is known as the molar mass. And its units are expressed in grams per mole. And yes, the abbreviation for mole is MOL. And so, copper's atomic mass, average atomic mass, is 63.546 atomic mass units. Well, if we express that mass in grams, we would have 63.546 grams of copper is 1 mole of copper. And if you counted the number of copper atoms in that 1 mole, or in that 63.546 grams, you would find 6.02 times 10 to the 23rd atoms of copper. And in chemistry, we find that it's necessary very frequently to be able to convert between moles and mass of a given element. For example, we know if 1 mole of copper is 63.546 grams, then 2 moles of copper is going to have a mass that's double that. Or if we had a half a mole of copper, its mass would be half of that of a mole. Of course, we don't always deal with nice round numbers like that. So what if we have 0.295 moles of copper? How many grams would that be? Well, we would set this up using dimensional analysis. Starting with our 0.295 moles of copper, make an X and draw a line, and bring the units that are currently in the numerator, which is moles, down into the denominator. And we need to use our conversion factor now. And so we will write 1 mole in the denominator and 63.546 grams in the numerator. And when we multiply across the top and divide what's on the bottom, then our moles will cancel, and we end up with 18.7 grams of copper. We can use the same process to work in the other direction. For example, if we had a specific mass of copper, 134.6 grams, how many moles would that be? Well, let's start with our given 134.6 grams of copper. Make an X and draw a line. And then take another look at that conversion factor. Not that one, this one right here, okay? Since now we're going from grams to moles, we want to bring grams down into the denominator. So we have 63.546 grams of copper, which is equal to 1 mole of copper. And when we multiply across the top and divide by what's on the bottom, we get 2.118 moles of copper. And so remember, when you're doing conversions like this, whatever units you want to end up with, just make sure they're in the numerator. And I hope this helped you to understand mole mass conversions.